When installing backup power transfer switches in residences utilizing inverter generators, it is important to be aware of certain technical considerations. Inverter generators, such as those from Honda, Yamaha, and Robin, often lack a groundable common on their alternating current output due to the H-bridge pulse width modulated design used to generate the 60 Hz output. This absence of a groundable common can present a safety hazard if not properly addressed during installation. Furthermore, inverter generators typically provide only 120 volts alternating current output, which may be insufficient for homes requiring 240 volts alternating current for appliances like dryers or electric stoves. Two potential solutions exist to overcome these challenges, both involving the use of an isolation transformer to establish a common ground connection at the breaker box. Firstly, a 120 volts to 240/120 volts isolation transformer can be implemented to create low and L2 size for an auxiliary breaker box. This configuration allows for the connection of 240 volts appliances and ensures ground fault protection, meeting code requirements for grounding and voltage compatibility. However, this solution may be more expensive compared to the second option. Secondly, a 120 volts to 120 volts isolation transformer can be used in conjunction with a transfer switch. This transfer switch connects the low and L2 sides of the auxiliary breaker box together when operating on backup generator power, maintaining load balancing. However, this approach restricts the use of 240 volts service breaker ports in the auxiliary box and may not fully comply with code requirements, particularly concerning separate ground fault circuit interrupters for each circuit. It is crucial to understand the function and purpose of the isolation transformer in these applications. The isolation transformer serves several key roles. 1. It provides galvanic isolation between the generator and the main electrical panel, preventing direct current flow and minimizing the risk of ground loops. 2. It establishes a neutral to ground bond, creating a safe and reliable grounding system for the generator output. 3. In the case of the 120 volts to 240/120 volts transformer, it steps up the voltage to provide both 120 volts and 240 volt circuits. Selecting the appropriate size and capacity of both the inverter generator and the isolation transformer is essential to meet the electrical demands of the residents. Overloading the generator or transformer can lead to overheating, damage, and potential safety hazards. Therefore, a thorough assessment of the home's electrical load is necessary before choosing the equipment. Regarding code compliance, the National Electrical Code, or NEC, provides specific guidelines for generator installations and transfer switches. It is imperative to adhere to these regulations to ensure the safety and legality of the installation. Some key NEC sections to consider include: firstly, Article 702, which covers optional standby systems, including generators. Secondly, Article 250, which addresses grounding and bonding requirements. Thirdly, Article 445, which pertains to generators themselves. Proper grounding is paramount for electrical safety. The grounding system should include a grounding electrode conductor connecting the generator frame to a grounding electrode, such as a ground rod or the building's grounding system. Additionally, a neutral to ground bond should be established to the generator or isolation transformer to provide a low impedance path for fault current. When using a transfer switch, it is crucial to select a listed and labeled device that is suitable for the intended application. Transfer switches are available in manual and automatic configurations. Manual transfer switches require manual operation to switch between utility power and generator power, while automatic transfer switches automatically detect power outages and switch to generator power. The choice between manual and automatic transfer switches depends on the homeowner's preferences and budget. Automatic transfer switches offer greater convenience and faster response times, but they are generally more expensive. It is essential to install the transfer switch correctly to prevent backfeeding, which can energize the utility grid and pose a serious hazard to utility workers. The transfer switch should be installed in accordance with the manufacturer's instructions and all applicable electrical codes. When installing a generator and transfer switch, it is highly recommended to consult with a qualified electrician. A qualified electrician has the knowledge and experience to ensure proper installation and code compliance. They can also identify potential safety hazards and recommend appropriate solutions. Furthermore, a qualified electrician can perform load calculations to determine the appropriate size of the generator and transfer switch. They can also ensure that the grounding system is properly installed and that all electrical connections are secure. In addition to the technical aspects of the installation, it is important to consider the logistical aspects. The generator should be located in a well-ventilated area away from flammable materials. It should also be protected from the weather. The transfer switch should be installed in a convenient location that is easily accessible. The wiring between the generator, transfer switch, and electrical panel should be properly sized and protected. The installation should be inspected by a qualified electrical inspector to ensure compliance with all applicable codes. The homeowner should be provided with clear instructions on how to operate the generator and transfer switch. They should also be informed of the potential hazards associated with generator use, such as carbon monoxide poisoning. Regular maintenance of the generator and transfer switch is essential to ensure their continued reliability. The generator should be serviced according to the manufacturer's recommendations. The transfer switch should be inspected periodically for any signs of damage or wear. The homeowner should also test the generator and transfer switch periodically to ensure that they are functioning properly. Using an inverter generator with a transfer switch can provide a reliable source of backup power during power outages. However, it is important to understand the technical considerations and to follow all applicable electrical codes. Consulting with a qualified electrician is highly recommended to ensure safe and code-compliant installation. Let's delve into the grounding considerations in more detail. In a typical residential electrical system, the neutral conductor is bonded to ground at the main service panel. This bond provides a reference point for voltage and helps to ensure that fault currents will flow back to the source, tripping a breaker and de-energizing the circuit. However, when using an inverter generator without a groundable common, this grounding scheme can be disrupted. Without a neutral to ground bond at the generator, fault currents may not have a clear path back to the source, potentially creating a dangerous situation. This is where the isolation transformer comes into play. By establishing a neutral to ground bond on the secondary side of the isolation transformer, a safe and reliable grounding system can be created for the generator output. This bond should be made in accordance with all applicable electrical codes. It is important to note that the grounding electrode conductor should be properly sized and connected to a grounding electrode, such as a ground rod or the building's grounding system. The size of the grounding electrode conductor is typically determined by the size of the service entrance conductors. In addition to the neutral to ground bond, it is also important to ensure that the generator frame is properly grounded. This can be accomplished by connecting a grounding electrode conductor from the generator frame to the grounding electrode. The size of this conductor is also typically determined by the size of the service entrance conductors. Proper grounding is essential for protecting against electrical shock and fire hazards. It also helps to ensure the proper operation of electrical equipment. When working with generators and transfer switches, it is important to take all necessary precautions to prevent electrical accidents. Always disconnect power before working on electrical equipment. Use properly insulated tools and equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electrical equipment, consult with a qualified electrician. Regarding the voltage considerations, it is important to understand the difference between 120 volts and 240 volt circuits. 120 volt circuits are typically used for lighting, small appliances, and receptacles. 240 volt circuits are typically used for large appliances such as electric stoves, dryers, and water heaters. In a typical residential electrical system, both 120 volts and 240 volt circuits are supplied. The 120 volt circuits are supplied by one leg of the 240 volt service. The 240 volt circuits are supplied by both legs of the 240 volt service. When using an inverter generator that only provides 120 volts output, it is necessary to use a step-up transformer to provide 240 volts power. This can be accomplished by using a 120 volts to 240/120 volts isolation transformer, as mentioned earlier. This type of transformer has two secondary windings, one that provides 120 volts and one that provides 240 volts. The 120 volts winding can be used to supply 120 volt circuits, while the 240 volts winding can be used to supply 240 volt circuits. It is important to note that the capacity of the transformer must be sufficient to handle the load of the 240 volt circuits. If the transformer is too small, it may overheat and fail. When installing a step-up transformer, it is important to follow all applicable electrical codes. The transformer should be properly grounded and protected by a circuit breaker. The wiring between the transformer and the electrical panel should be properly sized and protected. The installation should be inspected by a qualified electrical inspector to ensure compliance with all applicable codes. In addition to the grounding and voltage considerations, it is also important to consider the load requirements of the residence. The generator and transfer switch must be sized to handle the anticipated load. This can be accomplished by performing a load calculation. A load calculation involves adding up the wattage of all the appliances and equipment that will be powered by the generator. The total wattage is then divided by the voltage to determine the amperage. The generator and transfer switch must be rated to handle the calculated amperage. It is important to note that the load calculation should include both the continuous load and the intermittent load. The continuous load is the load that is always on, such as lighting and refrigerator. The intermittent load is the load that is only on occasionally, such as air conditioners and power tools. The generator and transfer switch should be sized to handle the peak load, which is the sum of the continuous load and the intermittent load. When performing a load calculation, it is important to use accurate wattage ratings for all appliances and equipment. The wattage rating is typically found on the nameplate of the appliance or equipment. If the wattage rating is not available, it can be estimated using the following formula: watts equals volts times amps. It is also important to consider the starting wattage of motors. Motors typically draw several times their running wattage when they start. The generator and transfer switch must be sized to handle the starting wattage of the largest motor. In addition to the technical considerations, it is also important to consider the cost of the generator and transfer switch. Generators and transfer switches can range in price from a few $100s to several $1,000s. The cost will depend on the size, features, and quality of the equipment. It is important to shop around and compare prices before making a purchase. It is also important to factor in the cost of installation. Installation can be a significant expense, especially if you hire a qualified electrician. When choosing a generator and transfer switch, it is important to consider your budget and your needs. Select equipment that is reliable, safe, and code compliant. Consulting with a qualified electrician can help you to make the right choice. Furthermore, understanding the different types of transfer switches is crucial for a successful installation. There are primarily two types: firstly, manual transfer switches, and secondly, automatic transfer switches. Manual transfer switches require the user to manually switch between the utility power and the generator power. This is typically done by flipping a switch or moving a lever. Manual transfer switches are less expensive than automatic transfer switches, but they require more effort to operate. They are suitable for situations where the homeowner is present and able to manually switch to generator power during an outage. Automatic transfer switches, on the other hand, automatically detect power outages and switch to generator power. This is done by sensing the loss of voltage on the utility power line. When a power outage is detected, the automatic transfer switch will start the generator and switch the load to the generator power. Automatic transfer switches are more expensive than manual transfer switches, but they offer greater convenience and faster response times. They are suitable for situations where the homeowner may not be present during a power outage, or where a quick restoration of power is critical. When selecting a transfer switch, it is important to consider the voltage and amperage ratings. The transfer switch must be rated to handle the voltage and amperage of the generator and the electrical panel. It is also important to consider the number of circuits that the transfer switch can handle. The transfer switch should be able to handle all of the essential circuits in the home, such as the lighting, refrigerator, and heating system. In addition to the manual and automatic transfer switches, there are also hybrid transfer switches that combine the features of both types. Hybrid transfer switches typically have a manual override that allows the user to manually switch to generator power if desired. This can be useful in situations where the automatic transfer switch fails or where the user wants to manually control the transfer process. When installing a transfer switch, it is important to follow the manufacturer's instructions carefully. The transfer switch should be installed in a location that is easily accessible and protected from the weather. The wiring between the transfer switch and the electrical panel should be properly sized and protected. The installation should be inspected by a qualified electrical inspector to ensure compliance with all applicable codes. Finally, let's discuss some additional considerations for using inverter generators for backup power. Inverter generators are known for their quiet operation and fuel efficiency. They also produce clean power, which is important for sensitive electronic equipment. However, inverter generators typically have a lower power output than traditional generators. This means that they may not be able to power all of the appliances and equipment in a home. When using an inverter generator for backup power, it is important to prioritize the essential circuits such as the lighting, refrigerator, and heating system. Non-essential circuits such as the air conditioner and power tools should be turned off to conserve power. It is also important to avoid overloading the generator. Overloading the generator can damage the generator and the appliances and equipment that are connected to it. The generator should be operated in accordance with the manufacturer's instructions. The generator should be properly maintained to ensure its continued reliability. The oil should be changed regularly, and the air filter should be cleaned or replaced as needed. The spark plug should be inspected and replaced as needed. The generator should be stored in a dry and well-ventilated area when not in use. By following these guidelines, you can safely and effectively use an inverter generator for backup power. Remember to consult with a qualified electrician to ensure a safe and code-compliant installation. The potential safety issue regarding the use of a 120 volts to 120 volts isolation transformer with a transfer switch connecting the lone and L2 sides of the auxiliary breaker box together when on backup generator power stems from the potential lack of independent ground fault protection for each circuit. In a standard electrical panel, each circuit is typically protected by a circuit breaker and a ground fault circuit interrupter, or GFCI. The GFCI is designed to detect small imbalances in current flow, which can indicate a ground fault. When a ground fault is detected, the GFCI will quickly trip the circuit breaker, preventing electrical shock. However, when the lone and L2 sides of the auxiliary breaker box are connected together, the GFCI protection may be compromised. This is because a ground fault on one side of the circuit may not be detected by the GFCI on the other side of the circuit. This can create a dangerous situation, as a person who comes into contact with a ground fault may not be protected from electrical shock. To address this potential safety issue, it is recommended to install individual GFCIs for each circuit in the auxiliary breaker box. This will ensure that each circuit is independently protected from ground faults. Alternatively, a 240 volts GFCI breaker can be used to protect the entire auxiliary breaker box. However, this may not be feasible in all situations, as it may require a larger breaker box and additional wiring. When considering the use of a 120 volts to 120 volts isolation transformer with a transfer switch, it is important to carefully evaluate the potential safety issues and to take appropriate measures to mitigate them. Consulting with a qualified electrician is highly recommended to ensure a safe and code-compliant installation.